Y'all ready for your first mixed model in R? Let's not ado any further. Let's step into R.
Ooh, it's so cozy in here.
All right, well, the first thing I'm going to do is I'm going to install the lme4 or lme4 package. Actually, I'm not going to do that because I've already done it, but that's what you would do if you were following along. So go ahead and install it, and then after you do that, be sure to comment it out so you don't accidentally reinstall it every time, because it's kind of a waste of time. Anyway, after doing that, I'm going to go require lme4 because we're going to use it. And I'm also going to require FlexPlot because I created FlexPlot and it's amazing. And then I'm going to read in a dataset that we're going to use for mixed modeling. And you can get this at my website at quantsite.net. There's the link right there. Hopefully it's still around in 6 months or whenever you're watching this video. Hi, how's the future? And now if I view D kind of sounds like beauty. And now after I read in our dataset and I view D original, we've got person ID, life events, parental depression, SES, and then we've got depression scores at time 1, time 2, time 3, time 4, and stress scores at time 1 through 4. Uh-oh, we've got a problem. The problem is when you're doing mixed models, you can't have it in wide format like that. It has to be in long format. So let's go back into R and I'll show you how to put it into long format. All right, to do so, I'm going to require tidyverse because tidyverse has the function to do it. And then I'm going to take D original, and then I'm going to, let me make this a little bit bigger, pivot longer. And the columns that I want to pivot longer, or the columns that I want to have stacked, are depression 1 through, how come I can't scroll over? There we go. Stress 4. So I'm saying take those columns and stack them basically. And this right here, I don't have time to explain right now what it's doing, but basically it's saying I need you to create 2 columns, one dot value, which is basically going to take the depression, the name of depression or stress, and then it's going to take the 1 through 4 and it's going to convert that to a variable called time. And then this is the pattern it's going to follow. I don't have time to explain the pattern, but if you're interested, I can link the video in the description for pivoting to give you an explanation of that. But once I do that, if I now look at my data, I'm going to use head instead of view so I can view it in the same window. Let me do it again. Give myself a wider screen so it'll show me more variables at one time. There we go. So we got person ID, and notice person ID is now repeated 4 times because there were 4 time points before. And we got life events, parental depression, and then SES. So all that looks the same. Now we've got a new variable called time that is 1, 2, 3, and 4. And our depression scores, which used to be in columns, are now in rows. So we've got that, and we've got stress. Now, ask yourself which one of these variables could be modeled as a random effect. I'll give you a hint, only the ones that vary within a person's ID. So if we look at this data set, there is one person's ID. Notice all their life event scores are the same, as well as their parental depression, as well as their SES. So that cannot be modeled as a random effect. And for more information on that, I'll go ahead and leave a video in the description that basically teaches you how to identify which variables could be fixed in random. But time could be modeled as well as depression and stress. So yay, wahoo. Now we are finally ready to model this as a mixed model. But before I show you how to do that in R, I'm just going to give an overview of what the syntax looks like in R. All right, so the mixed model notation, it's important to identify 4 different elements. 1, the outcome variable. 2 is the fixed predictors. 3 are the random predictors. And 4 is the cluster variable. And so the syntax for a very simple model might look like something like this. So we got y tilde a plus x vertical pipe ID, comma, data equals d. Right here is your outcome variable, just as it is with a regular regression model. Right here are where you put the fixed effects. And right here is where you put the random effects. And then right here is where you put the cluster variable. Notice that all the random effects also have fixed effects, and that's important. Every time you model a random effect, it also has to have a fixed effect. And so this model is saying that A is a fixed effect only, and X has a random effect as well as its fixed effect, because all random effects also have fixed effects. Let's look at another model.
Woohoo! Multiple fixed effects! What happens when you got multiple fixed effects?
So here we've got A1 and A2, both of which are fixed effects, and because they're fixed effects, notice neither A1 nor A2 are within the parentheses, because again, they are fixed effects only. And then X is the same as before. It's got a random effect and it's got a fixed effect. How about multiple random effects? I'm glad you asked. Here we've got only one A variable. Now we have x1 and x2, and notice that we have x1 and x2 both within the parentheses and outside the parentheses, because again, let me emphasize, every time you model a variable with a random effect, it also has to show up in the fixed effect area too. And what about multiple fixed and random effects? It might look like this, where you got A1 and A2, both fixed effects, x1 and x2, both random effects, but again, it shows up in the fixed area too. So you getting a feel for how the syntax goes? Now let me talk about some unusual models. So let's say you have a model with no random slopes at all. And so you might have a model that looks like this, y tilde a plus parentheses 1 vertical pipe ID. Why is that 1 there? Well, really the 1 is there because if you have no random slopes and you just leave that blank, it's going to give you an error. R is expecting to have something there, so you have to put a 1 there. More importantly though, that 1 tells R that you want the intercepts to be random. And if we go back to our simple model, y tilde a plus x plus parentheses x given ID, implicit in this, there is a 1 there. But R just assumes by default that there is a 1 there. And so you don't have to specify it. However, if you have no random slopes like in this model, you do have to specify it. Kind of annoying. I wish lme4 was a little more consistent, that you either always had to put the 1 there or never had to put the 1 there, but it is what it is. So again, if you have no random slopes, you got to put that 1 there. How about a model with no predictors at all? And we would call that a random effects ANOVA. So that's what this syntax would look like. Y tilde 1 plus 1 vertical pipe ID. And what is that doing? That's basically telling the model to fit a mean for each of the clusters. And a lot of times you'll fit these models just as a baseline. So you can start to kind of sort of compute R squared, but FlexPlot actually does that for you, so it's not necessary for you to do that. But again, if you want to fit a model with no predictors and you just want to estimate the mean for each of the clusters, that's what this does. And for another unusual model, let's say you want to fit a model where all the intercepts are fixed. Like I said in the introductory video to HLM, that's usually a bad idea, but maybe you have a theoretical reason to do it. This is how you would do it. So you go y tilde a plus x minus 1 plus x. Remember earlier I said that R always assumes that there is an intercept there, unless you have no random effects, in which case you got to put the 1 there. Well, to explicitly remove the intercept, you would do a -1. That's basically how you tell R, don't allow the intercepts to randomly vary. Make sure they're all the same. Again, this model usually doesn't make sense, but I'd hate to say never fit that model if there really was a good reason to fit it. So there you go. Now let's jump back into R. Ah, it's just as I left it. Now we're ready to model this as a mixed model, and let's fit a model where we've got depression as the outcome, and then we've got parental depression as a fixed effect, because again, that doesn't change within individuals, at least in our data set. And then we're gonna model stress as a random effect. And so to do so, I'm gonna use this code, depression tilde parental depression, which is our fixed effect, plus stress, which is our random effect. But again, all random effects have to be specified as fixed effects as well. And then we get our random effect here, given person ID. And if we fit that, we get, oh dear, warning message. Model failed to converge. That is a frustratingly common thing that you will find in mixed models. On my to-do list is to make a video about why this happens and how you can address it. But for this specific model, I know it's not a problem. I have done some diagnostics and checked it out and it's not a problem. But I'm not gonna go into that in this video because this is just an introduction. But once we fit our model, we can do summary, and that'll give you a lot of information that at this point you don't need to know. But if you're interested, if you go under the fixed effects, you can basically interpret these just as you would a regression model. Except instead of this being the lines for each of the individual ones, this is the average line across all the clusters. So this is saying that on average, assuming parental depression is whatever at its referent level is, and stress is at 0, we would expect your depression to be 6.97. And for every 1 point increase in stress, we expect your depression to go down 0.10145 points. So this is relative to the one category that isn't there, which is mild. And so relative to mild, moderate means you have, or if your parents have moderate depression, we expect you to have 1.29 more points on your depression score relative to somebody who has a parent who has mild depression. It's better to just look at these visually, and we'll go ahead and do that right now. So I'm going to visualize. So I'm going to just show you this visualization code. I'm not going to explain it because I'm going to do that in a future video. But I'm going to plot my first model and specify how it looks and sample 20 clusters at once. And then we get something that looks like this. If you're following along, chances are your plot's not going to look exactly like this, and that's okay. Just because it's randomly sampling from the clusters, which again, I'll explain that later. And so what do we find? Well, the first thing I'm noticing is the panels go mild, then moderate, then no, then severe. It seems like they should be in order. So I'm going to go ahead and make parental depression an ordered factor. So I'm going to take my code that I had earlier, and I'm just going to add on to it a pipe. Let me bring this back a little bit just so you can see it. Boo! And I am going to convert that into an ordered factor. So I'm saying it goes no, then mild, then moderate, then severe, and then I'm saying ordered equals true. And then if we did that and then run the model again, we still get that convergence failure, but that's okay. We don't care. I could run summary again, but I'm not going to. Instead, I'm going to visualize, and now those columns are in order. And so you'll notice that those regression lines get higher and higher as parental depression goes up, which makes sense. The more depressed your parent is, or parents are, the more we'd expect you to be depressed. And we also see that there is a relationship between stress and depression such that increases in stress tend to lead to increases in depression. So that's cool. Now looking at this, I'm noticing that those lines are essentially parallel. There's slight deviations from parallel, but they're basically parallel. So let's go ahead and get rid of stress as a random effect. And that's what I've done here. Notice we've got parental depression and stress in the fixed effects part, but now I've taken stress out. And like I said earlier, when you have no random effects, you have to put a 1 in there, otherwise R is going to get confused. And I'll actually go ahead and show that to you. If I run that, it'd be like, what? I don't know what you're trying to do, man. It says unexpected vertical pipe. Yeah, so basically all that means is you have to put a 1 there. And if I run that, we don't get the convergence failure anymore, which is nice. And then if we now visualize this model, it's not going to look all that different because the slopes were already pretty parallel before, and now they are exactly parallel. So, yeah. So yeah, that was a quick and dirty introduction, not too dirty, I hope, to mixed models in R. A very, very basic introduction. In the next video, I'm going to talk more in depth about visualizing mixed models and the complications that come up with mixed models and why they're hard to visualize and how FlexPlot handles the visualizations and that sort of thing. As a reminder, if you want to take a class with me, including a soon-to-be-coming mixed effects models class, please visit simplistics.net, where you can take self-guided classes, complete with quizzes and discussion boards and exams and interaction with fellow class members, or you can take a live class, which means you'll get to Zoom with me on a regular basis and ask questions of me and have me there to guide you through different practices and that sort of thing. I hope you join me because I would love to meet you. So with that, let's review our learning objectives. Number 1, know how to install and load the lme4 package in R. Number 2, I didn't emphasize it that much in this video. I just showed you how to do it, but it's still a learning objective, and that is wide versus long format for mixed models. And again, mixed models require a long format, not wide format. And so make sure you know how to do that. And if you need help, again, I will link the video in the description. Number 3, the syntax for mixed models. Number 4, be familiar with a random effects ANOVA, and that's the one that doesn't have any predictors, as well as models that only have the intercept as a random effect. And again, you have to put the 1 there, otherwise R is gonna bark at you. As well as how to remove an intercept. I don't know that that should be a learning objective, but I'm gonna make it anyway, just because that would be exceedingly rare to do that sort of a thing. So yeah, that's all I gotta say. Hey, good having you here. Hey, it's good seeing you today. Thanks for coming. I'll see you in the next video. Peace out.